Jai Hind everyone. I am Dublish, faculty of MC department in AKGC Engineering College. Today I am going to deliver a lecture on artificial intelligence, and my topic of today's lecture is searching algorithm. So, what is searching algorithm? Searching algorithm are one of the most important areas of artificial intelligence. Basically, problem solving agents in artificial intelligence. Techniques are universal problem solving method, rational agent or problem solving agent in AI mostly use these search strategies or algorithm to solve a specific problem and provide the best result. Problem solving agent are the goal based agent and use atomic representation. There are various problem solving searching algorithm. So, what are the searching algorithm terminologies? Searching is a step by step procedure to solve a search problem in a given search space. A search problem can have basically three main factors. First one is search space, second one is start state, and third one is goal test. So, what is search space? Search space is represent a set of possible solution which a system may have, and the start state is a state from where agent begin the search. And goal test, it is a function which observe the current state and return whether the goal state is achieved or not. Moving on, search tree. A tree representation of search problem is called search tree. The root of the search tree is the root node which is corresponding to the initial state. Action, it gives the description of all the available action to the agent. Transition model, a description of what each action do can be represented as a transaction model. Path cost, it is a function which assign a numeric cost to each path, and the solution, it is an action sequence which leads from the start node to the goal node. Optimal solution, if a solution has the lowest cost among all solutions. So, what are the properties of search algorithm? Basically, we have mainly four essential properties of search algorithm to compare the efficiency of these algorithm. Completeness, a search algorithm is said to be complete if it guarantees to return a solution if at least any solution exists for any random input. Optimality, if a solution found for an algorithm is guaranteed to be the best solution, lowest path cost among all other solutions, then such a solution for is said to be an optimal solution. Time complexity is a measure of time for an algorithm to complete its task. And space complexity is the maximum storage space required at any point during the search as the complexity of the problem. Now, types of the search algorithm. Based on the search problem, we can classify the search algorithm into uniform, uninformed means blind search, and informed search means heuristic search algorithm. So, blind search has 5 types. First one is breadth first search, uniform cost search, depth first search, depth limited search, iterative deepening depth search, and bidirectional search. And informed search divided in 2 parts: best first search and A star search. So, what is uninformed, or we can say blind search? The uninformed search does not contain any domain knowledge such as closeness, the location of the goal. Basically, it operates in a brute force way, as it only includes information about how to traverse the tree and how to identify leaf and goal node. So, uninformed search applies a way in which search tree search without any information about the search space, like initial state operators and test for the goal. So, it is also called blind search. It examines each node of the tree until it achieves the goal node. It can be divided into mainly 5 types: breadth first search, uniform cost search, depth first search, iterative deepening cost search, iterative deepening depth first search, and bidirectional search. Now, moving on, what is informed search? Informed search algorithm use domain knowledge. In an informed search, problems information is available which can guide the search. Informed search strategies can find a solution more efficiently than an informed search strategy. Informed search is also called a heuristic search. A heuristic, now what is the meaning of heuristic? A heuristic is a way which might not always be guaranteed for best solution, but guaranteed to find a good solution in reasonable time. Informed search can solve much complex problem which could not be solve in another way. Traveling salesman problem is a best example for the informed search. Again, informed search divided in two parts. First one is greedy and second one is A star search. Now, here we can identify what is the difference between informed search and uninformed search. Informed search basically use knowledge for searching the process, and uninformed search does not use knowledge for searching process. In informed search finds solution more quickly, but in informed search it finds solution slow as compared to informed search. Informed search may or may not be complete, but uninformed search always be complete. Informed search cost is low and uninformed search cost is high. Informed search consume less time, uninformed search consume moderate time. Informed search provide the direction regarding to the solution, and uninformed search no suggestion is given regarding to the solution. Informed search is less lengthy while implementation, but uninformed search is more lengthy while implementation. Example of informed search is greedy search, A star search, graph search, and uninformed search example are BFS and DFS. Now, what is uninformed search? Uninformed search is a class of general purpose search algorithm which operate in brute force way. Uninformed search algorithm do not have any kind of additional information about a state or search space other than how to traverse the tree. So, it is called the blind search. Now, we will study about what is breadth first search. Breadth first search is the most common search strategy for traversing a tree or a graph. This algorithm search breadth-wise in a tree or a graph, so it is called the breadth first search. Breadth first search starts searching from the root node of the tree and expand all successor nodes at the current level before moving to nodes of next level. The breadth first search algorithm is an example of general graph search algorithm, and breadth first search implemented using FIFO-Q data structure. Advantage of BFS is BFS will provide a solution if any solution exists. If there are more than one solution for a given problem, then BFS will provide the minimal solution which requires the least number of steps. The disadvantage of BFS is it requires lots of memory, since each level of tree must be saved into memory to expand the next level, and BFS needs lots of time if the solution is far away from the root node. Example of BFS is in the below tree structure we have shown the traversing of the tree or using BFS algorithm from the root node S to the goal node K, and BFS search algorithm traverse in layers, so it will follow the path which is shown by the dotted arrow, and the traversal path will be from S to A to B to C to D to G to H to E to F to I to K. The time complexity of BFS algorithm can be obtained by the number of nodes traversed in a BFS until the shallowest node, where D is equals to depth of the shallowest solution and B is the node at every state. So, time complexity is equals to 1 plus B square plus B cube plus B ki power D is equals to omega B ki power D. Again, space complexity of BFS algorithm is given by the memory size of frontier, which is again omega B ki power D, and completeness, as I told you earlier, BFS provide the complete solution, which means if the shallowest goal node is at some finite depth, then BFS will find a solution, and optimality, BFS is optimal if path cost is non-decreasing function of the depth of the node. So, this is all about the BFS. Moving on, depth first search. Depth first search is a recursive algorithm for traversing a tree or a graph data structure. It is called a depth first search because it starts from the root node and follow each path to its greatest deep depth node before moving to the next path. So, DFS uses stacked data structure for its implementation, and the process of DFS algorithm is similar to the BFS algorithm. Note that backtracking is an algorithm technique for finding all possible solutions using the recursion. So now the disadvantage of DFS is DFS require very less memory as it only needs to store a stack of the nodes on the path from root node to the current node, and again it takes less time to reach to the goal node than BFS algorithm. So if it traverses in the right path. What are the drawback of DFS? There is a possibility that many states keep reoccurring, and there is no guarantee of finding the solution. Also, the DFS algorithm goes for deep down searching, and something it may go to the finite loop. So this is the example of depth first search. In example, we have shown the flow of the depth first search, and it will follow the order as root node से traverse करेगा left node and then right node. It will start searching from root node S and traverse A, then B, then D, then E. After traversing E, it will backtrack the tree as E has no any other successor, and still goal node is not found. After backtracking, it will traverse node C and G, and here it will terminate as it found the goal node. So this is how DFS is working. Again, completeness. DFS search algorithm is complete within finite state space as it will expand every node within a limited search tree. Time complexity. Time complexity of DFS will be equivalent to the node traversed by the algorithm. So it is given by Tn 1 plus n square plus n cube plus n ki power m. So total time complexity is omega n ki power m, where m is equals to maximum depth of any node, and this can be much larger than d. D means shallowest solution depth, and space complexity. DFS algorithm needs to store only single path from the root node. Hence, space complexity of DFS is equivalent to the size of the fringe set, which is omega b ki power m. And again, it's the optimal. We will check for the optimality. So DFS search algorithm is non-optimal as it may generate a large number of steps or high cost to reach the goal node. Moving on, depth limited search algorithm. So depth limited search algorithm is similar to depth first search with a predetermined limit. Depth limited search can solve the drawback of the infinite path in depth first search. In this algorithm, the node at the depth limit will treat as it has no successor node further. Depth limited search can be terminated with two conditions of failure. Standard failure value, it indicates that problem does not have any kind of solution, and cutoff failure value, it defines no solution for the problem within a given depth limit. Again, advantage, depth limited search is memory efficient, and disadvantage are depth limited search also has disadvantage of incompleteness, and it may not be optimal if the problem has more than one solution. DLS search algorithm is complete if the solution is above the depth limit, and time complexity of DLS algorithm is omega b ki power l, and space complexity of DLS algorithm is omega b into l, and optimal DLS can be viewed as a special case of DFS, and it is also not optimal even if L is greater than D. Moving on, uniform cost search algorithm. Uniform cost search is a searching algorithm used for traversing a weighted tree or graph. This algorithm comes into play when a different cost is available for each edge. The primary goal of the uniform cost search is to find the path to the goal node which has the lowest cumulative cost. Uniform cost search expands nodes according to their path cost from the root node. It can be used to solve any graph tree where the optimal cost is in demand. A uniform cost search algorithm is implemented by the priority queue. it gives maximum priority to the lowest cumulative cost. Uniform cost search is equivalent to BFS algorithm if the path cost of all the edges is same. Now, the benefit and drawback of uniform cost search algorithm. The advantage are basically uniform cost search algorithm is optimal because it at every state the path with the least cost is chosen, and the drawback of uniform cost search is it does not care about the number of steps involved in searching and only concerned about the path cost, due to which this algorithm may be stuck sometime in an infinite loop. So, this is how uniform cost search is working. So, again uniform cost search is complete, such as if there is a solution UCS will definitely find out, and the time complexity is let C star is cost of the optimum solution and sigma is each step to get closer to the goal node, then the number of step is sigma C star upon epsilon plus 1. Here we have taken plus 1 as we start from state 0, and N2 C star upon epsilon. Hence, the worst case complexity, time complexity of uniform cost search is omega b ki power C star upon epsilon, and the space complexity, again same logic applies here for space complexity. So, the worst case of space complexity is same as the time complexity, and again it is a optimal. Uniform cost search is always optimal as it is only select a path with the lowest path cost. Moving on, iterative deepening first search. The iterative deepening search algorithm is a combination of BFS and DFS algorithm. This search algorithm finds out the best depth limit and does it by gradually increasing the limit until a goal is found. The algorithm performs deep first search up to certain depth limit, and it keeps increasing the depth limit after each iteration until the goal node is found. So, this search algorithm combines the benefit of breadth first search and depth first search memory efficiency. So, it is taking from breadth first search is taking fast searching, and from depth first search is taking memory efficiency. So, we can say कि iterative deepening search algorithm is a perfect combination of DFS and BFS. So, the iterative search algorithm is useful uninformed search when search space is large and depth of the goal stage is known. Advantage and disadvantage of iterative deep first search is it combines the benefit of BFS and DFS search algorithm in terms of fast search and memory efficiency, and the main drawback of iterative deep first search is that it represents all the work of the previous phase. So, here we understand the example. This is the example for iterative deepening first search. Following tree structure is showing the iterative deepening first search. Iterative deepening depth first search algorithm perform various iteration until it does not find the goal node. So, the iteration performed by the algorithm is given as first iteration is what A, and from second iteration it will take ABC, and from third iteration A B C D E A B D E, next then C, then F, and then G. In the third iteration we can say the algorithm will find the goal node. So, completeness, so the algorithm is complete if the branching factor is finite, and time complexity, let us suppose B is the branching factor and depth is D, then the first time complexity is omega B ki power T. Space complexity, the space complexity of iterative depth deepening first search will be omega B ki power D, and optimality, again IDDFS algorithm is optimal if path cost is non-decreasing function of the depth of node. So, this is all about today's lecture. Thank you everyone. Jai Hind.